In the previous video, we discussed design patterns in general. In this video, we'll be discussing the Singleton pattern and we'll see how to implement it in an application. The Singleton pattern ensures that only one instance of a given type exists in your application's lifetime. This is achieved by creating a single instance of an object within the singleton and by making the initializer private to prohibit outside instantiation. Any further reference to the singleton object simply refers to the underlying instance. This pattern can be used for modeling finite real-world resources like a server or a printer. For example, perhaps your object manages a connection to a printer. Instantiating a second instance of your object doesn't create a second printer in the real world. So singletons allow you to create a shared instance that allows your single object to be used throughout your application. I should note that there's a lot of controversy about singletons. I've provided some links to some excellent discussions on this video's resource page. But to name a few, singletons can make your application difficult to test. They are often used as a hack to create global instances, usually to avoid the work of passing values properly. For the most part, you should rarely use singletons. In fact, one of the main reasons why I've chosen to include singletons is to warn you to actually resist the urge to use them. You can download the Singleton project files on this video's resource page. Once your project has loaded, open up the file named logger. Here we have a simple logger class with some properties, a write function and a read function. The problem is that this class can be instantiated over and over, with each instantiation pointing to the same file. This can be problematic when you consider multiple processes writing to the same log simultaneously, and before one process can finish, another process tries to log using another instance. This is one of the few times when a singleton class is appropriate, since our logger may have limited resources, such as a synchronous database connection or a log file. Now, there are many ways to create a singleton class. However, the one that I'm going to show you is considered the best practice by both Apple and the Swift community. You can visit this video's resource page for references to this. At the top of our class, we'll add a static let named shared instance. This shared instance will hold the one and only instance of our logger class that will be possible in our application. We ensure that this is the case by including the private keyword on our initializer, making it impossible to instantiate multiple instances outside of our logger class. Of course, now our instance of logger in our view controller is broken. If we look at our instance, it says logger cannot be constructed because it has no accessible initializers, which is precisely what we wanted. So, we can update our calls to logger by changing our calls to logger.sharedInstance.write. We can now use this singleton anywhere in our application. There are some complexities, however, when dealing with finite resources and concurrency. For example, what if we try to write to our logger from multiple threads at once? Let's see what happens. In the viewcontroller.swift file, add a function named runBackgroundLogs. We'll call this function just above our for-in loop. I'll paste in a background queue implementation, which should be familiar to you. Notice that our background queue is simply performing the same loop as before. Let's run our application and see what happens. Just as expected, we receive a runtime crash. This is a key example as to why singletons should be used with caution. This is a simple fix, however. We'll head over to our logging class and use Grand Central Dispatch to resolve our problem. So, the problem at hand is that our application is attempting to access our data source concurrently. We need to force our write method to handle requests in serial. We'll add a private constant named q and give it a value of dispatch_q_create. I'll add an identifier named logq with a type of dispatch_q_serial, which gives us a serialized queue. Next, we'll wrap the contents of our write operation with a call to dispatch_sync, and we'll give it our queue to work with. This should do it. Build and run, and your application should work flawlessly. In this video, we have looked at the correct way to implement a singleton in Swift 2. In the next video, we're going to take a look at our second creational pattern, the factory pattern.